Now here's an example for you to try. We have a normal distribution here, and it wants you to find these probabilities. So go ahead, pause the camera, give this your best shot, and then you can start the camera back up and see how you did. Okay, so let's see how you did here. So it says here the weight of Krispy Kreme potato chips. Those don't sound good, do they? Is normally distributed with a mean of 13.47 ounces and a standard deviation of 0.64 ounces. And it wants you to find the following probabilities. So this first one, the first step is to write the x-score probability. So this would be the probability that x is less than 13. Okay, now I draw a diagram. Okay, in the center goes the mean, 13.47. The standard deviation below that. 13 ounces is below the mean somewhere, and I want the bags that are less than that. So step 3, I calculate the z-score. So I'm going to take 13 minus 13.47 and divide that by 0.64. And this will give me the z-score here. So 13 minus 13.47. Divide that by 0.64. And it looks like I get a z-score of a negative 0.73. So now I write the z-score probability. So I've changed my x to a z, the 13 to the corresponding z-score. And now I find the z-score probability. So I'm going to get the area below. So this is like the first case, and the first case is the less than probability. All you have to do is look it up on the table, and the area on the table is the area that you want. So negative 0.73. These cross at 0.2327. 2327. And that is the probability I'm looking for. So, and you can also think of it as 23.27% of the products have a weight below 13 ounces. Okay, so now this next one, you want to find the probability that it's greater than 15. Okay, so step 1 is you write the z-score probability. So probability that we want to write the x-score probability. The probability that x is greater than 15 ounces. So second step here is draw my diagram. The mean in the center. Standard deviation below that. 15 is going to be up here somewhere, and we want the weight of the products above that. So now I calculate the z-score. This is my third step. So 15 minus 13.47 over 0.64. 15 minus 13.47 divided by 0.64. So 2.39. 2.39. Okay. So now I want the probability that I'm going to write the z-score probability. I'm going to change my x to a z is greater than 2.39. So this is like the second case, a greater than probability. So I'm going to look up this z-score, and then I'm going to need to subtract that area from 1. So I'm going to go to the positive side, look up 2.39, and I get 9916. So this is 0.9916. And so this is 1 minus 0.9916. So 1 minus 0.9916 gives me, that's scientific notation. I think I can change that. Change my norm to 2. Yeah. So this is 0.0084. And that's my fifth step. 0.0084. Okay, so that's a greater than probability. Finally, we got this between probability. This is like the third case, right? So the first step is I write out the z-score probability, 14 less than x less than 16. And now I'm going to draw my diagram. So the mean here again is 13.47. 14 is up above the mean somewhere. 16 is up above even further. And I want to find the area between these two. They're both above the mean. So now what I need to do is find the z-score for each one. So 14 minus 13.47 divided by 0.64. So 14 minus 13.47 divided by 0.64. I get, it's going to be 0.83, positive 0.83. And now I'm going to do 16 minus 13.47 divided by 0.64. So let's see what that is. 16 minus 13.47, divide that by 0.64, and it looks like I get 3.95. Okay, so that's pretty extreme here. So now I write out my z-score probability, change these to the z-scores, 0.83 less than z less than 3.95. And now I'm going to find the area. So this is like the third case. This is a between probability. So when I look up this one, I get all the area from this z-score all the way down. That's too much. I want to subtract the area below that. So when I go to look up 3.95, I notice the table only goes to 3.49. So when you get a number that's greater than 3.49, we're going to use 0.9999. That's as big as you can get to 4 decimal places without just being 1. And so now I look up 0.83. I get 7967. Okay, and so my final probability is the difference between the two areas. So 0.9999 minus 0.7967. And that should be a 7 there. And I get 0.2032. And that is the area between the two, between 14 and 16, or that's the probability that a randomly selected bag will be between 14 and 16 pounds, or ounces.